Hello viewers, welcome once again to UMass Media for another awesome class. The last time we looked at introductory part to number basics and we solved the problem of conversion of base 2 numbers or other bases to base 10. Today we are going to continue in that series. The last class we dealt with whole numbers. Today we are going to deal with decimals. How to convert decimals that are in base 2 or base 3, other bases to base 10 because we follow the same approach. I'm going to drop a link of the last video at the description of this video. In case you have not watched it, do well to watch it so that you can understand the basics which we dealt with the last time before you can delve into today's class. What we have, we'll be looking at conversion of decimals, decimal bases to base 10. For today, we are going to look at an example. 1100.1101 base 2. Now we want to convert this to base 10. I want you to follow this step by step as I explain. Like what we did in the last class, it is continuous multiplication, which involves the multiplication of each digit by the base raised to power the position of each digit minus 1. Now let's go. We look at the whole number part, which is 1100. It has 4 digits. 4 minus 1 gives us 3. So we are going to have 3, 2, 1, and 0. Then here is going to be minus 1, minus 2, minus 3, and minus 4. So let's go. 1 times the base raised to power 3 plus 1 times the base raised to power 2 plus 0 times 2 raised to power 1 plus 0 times 2 raised to power 0. Now this is the whole number part. Let's deal with this first. Here we have 1 times 2 raised to power 3, that gives us 8. 2 times 2 times 2 plus 1 times 2 raised to power 2, that's 4, plus 0 times 2 raised to power 1, that's 2, plus 0 times 2 raised to power 0, that's 1. Now this gives us 8 plus 4 plus 0 times 2 gives us 0, plus 0 times 1 gives us 0. And that's equal to 8 plus 4 equal to 12. Now we are not done. This is just the whole number part of this base 2 number. Let's go back to the decimal part. At the end of the day, we are going to add 2 of them together. Now for the decimal part, we have 1 times 2 raised to power minus 1 plus 1 times 2 raised to power minus 2 plus 0 times 2 raised to power minus 3 plus 1 times 2 raised to power minus 4. Now, according to the law of negative index, we understand that 2 raised to power minus 1 will give us, let's assume this minus to be 1, then we have all over 2 raised to power the positive index. It means 1 all over the base raised to power the positive index. So the positive index of minus 1 gives us 1. That's plus 1. Plus 1 times 1 all over 2 raised to power 2. Plus 0 times 1 all over 2 raised to power the positive index 3. Plus 1 times 1 all over 2 raised to power the positive index 4. Okay, 1 times 1 gives us 1. Remember, this is all over 1, all over 1, all over 1, all over 1. Now 1 times 1 gives us 1. 2 raised to power 1 is 2, 1 times 2 is 2. So we have 1 all over 2. Here we have 1 times 1 is 1, all over 2 raised to the power 2 is 4. 1 times 4 gives us 4. Plus Now 0 multiply anything gives us 0, so let's not waste our time on that. So we have 0 here, plus 1 times 1 gives us 1, all over 2 raised to the power 4, that gives us 16. That's 2 times 2 times 2 times 2. We have 16. Okay, now to continue solving this problem, we are going to follow the approach for addition of fractions. Now let's look at the denominators of these fractions. We have 2, 4, and 16. The LCM of 2, 4, and 16 is 16. So we have 16. 2 divided 16 gives us 8. So we have 1 times the numerator 1 times 8. Here we have 1, the numerator, times 4 divided 16 gives us 4, plus, let's eliminate 0, 16 divided 16 gives us 1. So we have 1, which is the numerator here, times the dividend we got, which is 1. 1 times 8 gives us 8, plus 1 times 4 gives us 4, plus 1 times 1 gives us 1, all over 16. 8 plus 4 is 12, plus 1, 13. So we'll have 13 all over 16. Now to complete the solution of this problem, the conversion of this decimal base to base 10, let's add the solution we got from the whole number part to the solution we got from the fraction part or the decimal part. And that is, therefore, we have 12 plus 13 all over 16. We still solve this again using addition of fractions. The LCM of 1 and 16 is 16. 1 into 16 is 16, so we have 12 times 16 plus 16 into 16 is 1. We will have 13 times 1. Okay, 12 times 16, if you do your multiplication well, is going to give us 192. So we'll have 192 plus 13 times 1 is 13, all over 16. 192 plus 13, that is going to give us 205, then all over 16. Now let's see if we can reduce to the lower term. There's no common factor between 205 and 16, so we simply convert to mixed fraction. 16 into 20 gives us 1, remainder 4. We put that 4 here, that gives us 45. 16 into 45 gives us 2. That is 16 times 2 is 32. 45 minus 32. 5 minus 2 is 3. 4 minus 2 is 1. So we have 13 all over 16. This gives us the solution to this conversion. I want you to take time and watch this video over and over again and ensure you get all the steps that we have. But in case you are confused anywhere, feel free to ask questions in the comment section below and I will attend to it. See you next time, next class, same channel.